Okay, right. Now you see that, okay, whatever he has taken on y-axis, I am taking it on x-axis. And this voltage, I am not taking on the y-axis. Sir, is that your will and pleasure that you take anything you want? Okay, good. Now, let me go back to this experiment. Okay. When I go to the experiment, what do I have? I have a nickel crystal constantly placed. And I have a detector because of which I can change this theta. Okay, I can change theta. Now that theta is nothing but your phi in this particular diagram. Okay, in this particular diagram, whatever phi I'm talking about is theta in this particular diagram. Okay, so phi is the variable. And what is V? What is V? Okay, this 44 volts or whatever it is. What is V? That V is nothing but the potential that is provided by this A. Okay, what is A? This is actually trying to create a potential difference between these two things so that the electrons will accelerate with higher or lower velocity. That implies it is an accelerator, particle accelerator. Okay, now with A, okay, that means this, okay, this is the potential V. Okay, that means this is the second variable that I have. After that, what do I have? After that, what do I have is on this detector, I have a galvanometer. That means that will actually measure the intensity. That will measure the intensity. So there are three variables here. One is phi. Okay, angle of incidence to angle of reflection, total angle phi. And the second thing is potential or V. Okay, with which you can accelerate the electrons. Okay. Now, okay, why do you want to accelerate electrons, sir? Now, you know that your friend has said that when you accelerate electrons, the wavelength of the electrons changes. How is that, sir? Nothing. Lambda is equal to h by under root 2 MEV, where V is the potential now. Okay. So as you change the potential, lambda changes. So we have a particular V also, right? That means V is a variable, phi is a variable, and the galvanometer, that implies intensity. Intensity is also another variable. So what will I do? I will try to perform the experiment by taking the detector with very, very small angles. Okay, I'll take the detector at very, very small angle. Okay, and then keep on increasing my angle. So let me say I'll take 2 degrees. Okay, or let me say 10 degrees. Okay, perform the experiment. Then 20 degrees, perform the experiment. That means find out what is the intensity received by the galvanometer. Okay, so for theta is equal to 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. I'll find out what is the intensity. Okay, that's one tabular column. After that, I will change the potential from initially, let me say 20 volts. Now I'll take it to 30 volts. Okay, then again I'll repeat the experiment. That means, okay, for theta is equal to 10, find the intensity. 20, find the intensity. 30 degrees, find the intensity. 40 degrees, find the intensity. 50 degrees, find the 60, 70, 80, 90, 100, find the intensities. Okay. So what am I doing? For different voltages, for different theta values, I am trying to find out intensities. I am trying to find out the intensities. Okay, so I'll repeat it. Okay, so right now, okay, when I take it for small angles, usually the intensity will be very large, and as I go to the higher angles, the intensity continuously falls, and this is what is expected. Okay, this is what is expected. Okay, that means for low angles, the intensity is expected to be very, very high. Okay, for very low angles, the intensity is expected to be high. Okay, you see, okay, for smaller angles, okay, the intensity is very large, and after that it is decreasing. Okay, let me talk about later. Okay, now this is what is expected. But what it is found is at 50 degrees. Okay, at 50 degrees, I found something to be different. What is that? Okay, what I found is at 50 degrees, I found a small bump. That means at 50 degrees, I found a small bump. Okay, that's going on like this. Okay. Okay, excuse me for that. Okay. So I at 50 degrees, I found a bump. Oh, I doubted it. Then what did I do? I repeated the experiment n number of times, but every time at 50 degrees, I am getting a small bump. Oh, then I said, okay, there should be something, okay, particular something happening at 50 degrees. Then what did I do? From okay, different voltages, I found that this peak was okay, a little clear at 44 degrees. Okay, then what did I do? Okay, I started increasing the potential from 44 to, let me say, 48 degrees. Okay, and I found that the bump was okay, a little bit more prominent. Okay, at the same angle. Okay, at the same angle, the bump was a little bit more prominent. Okay, like this. Okay, then I repeated the experiment with 58 degrees or 54 degrees. I got the peak to be very prominent. Then what did I do? I did repeat the experiment with let me say after 54, I repeated it with 58 degrees. I got the peak to be decreasing. I repeated it with 64. Okay, then I got the peak to be much smaller again. So first, what did I do? For a given voltage, I try to find out different intensities at different angles. So at different theta values, I found that the theta was intensity was continuously decreasing except at 50 degrees. At 50 degrees, there was a sudden, small change. So when I repeated the experiment n number of times, the change was same at 50 degrees. That means there was some deviation from a continuous decrement. What did I do? Now I changed the potential. For different values of potential I verified, but I found that the peak prominence started at 44 degrees, 44 volts. At 44 volts, the peak was very clearly visible. That means the variation was clearly visible. I increased 45, 46, 47, 48, 49, 50, 51, 52, 53, 54. Okay. And then 56, 56, 57, 58, 59, 60, like that. What I found is, I found this peak to be very large for 54 volts at the 50 degrees. So I found that these two values have something to do with the experiment. Okay, some peculiar changes are happening at these values of voltage and angle. Okay, so that is my intensity taken at different values. That means I have to repeat the experiment n number of times. Okay, now that is what is actually shown even in this, except that now the graph is plotted between theta and voltage. Okay, theta and voltage. So what happened is, it gave an excellent peak for 50 degrees. Okay, this is different and this is different. Okay, intensity. Okay, it gave high beautiful intensity at 50 degrees. Okay, so now I'll go back to this. Okay, 21. Okay, yeah, 21. So that's what is understood in matter. 44 volts, okay, 48 volts, 54 volts, and 64 volts. Okay, and it is found that for 54 volts and 50 degrees, it gave the most prominent peak. Okay, that's it. That is the experimental value. Now, from that, they tried to understand why those two values only. Okay, so this voltage is 54 volts. Okay, you see this voltage is 54 volts and this angle is 50 degrees. 54 volts and 50 degrees, you got a very excellent prominent peak. Now, okay, if you want to see this 50 degrees, you have to see this 50 degrees here. Okay, this is the 50 degrees. Okay, ఇక్కడ పక్క parallel planes cursor move అవుతుంది కదా. Okay, here this is the 50 degrees. Okay, this is the incident ray, this is it. Okay, and these are the set of parallel planes. See, dots and these are the places where you have your atoms or lattice points. Okay, these are the lattice points. Okay, of the crystal plane. So this is the set of parallel planes of the crystal, which is actually reflecting and giving you constructive interference, right? Okay. From Bragg's law, the path difference between this ray reflecting from the first plane and the one which is getting reflected from the second plane is 2d sine theta. And if this, okay, if this path difference is equal to n lambda, then you will have constructive interference. I'll take n is equal to 1 in this case. So lambda is equal to 2d sine 65. Theta is equal to 65. Where did we get the 65? Nothing. Okay. Theta is taken with respect to the plane and not the normal. In Bragg's law, theta, that is 2d sine theta, theta is taken with respect to the plane and not the normal. Okay. So what is the angle between the normal and the incident ray? Half of 50, that is 25. Okay. So what will be this angle? This angle will be 90 minus 25, that is 65 degrees. Okay. So 2d 65.